So, trigonometric questions that deal with real life problems such as kite flying and buildings and that kind of stuff. So, we take question 10 here. Write tan 45 as a fraction in terms of y. So, anytime you get a question and you have to deal with one triangle out of two, write the triangle separately to the question. 45 here. And what I tell you to do, I always tell you to label the triangle. H and A touch off the angle, and H is the longest side. Got my right angle in. So O is here. So we have a Y and we have a 4. So we're asked to write tan 45 as a fraction in terms of Y. So O and A, maybe you should put SOHCAHTOA at the top of each page until you absolutely know you're not going to make any mistakes. Tan, opposite and adjacent. So the tan of 45 is equal to O over A. So you can say the tan of 45 is equal to Y over 4. And that's writing tan 45 as a fraction in terms of Y. It's done. Okay. So now use your calculator to find the value of tan 45. And if you type tan 45 into your calculator, a 45-degree angle is based on a right angle triangle where these two sides here, or these two angles are 45. Now if they're both 45, we can say that these sides are the same length. So the tan of 45 is equal to 1. Probably something that you should remember. Okay. Use your answers from part A and B to find the value of Y. So now we have that 1 is equal to Y over 4. So Y, you can see 4 over 4 is equal to 1. So Y is equal to 4. It doesn't give us any centimeters or anything here, so we'll just say units for now. And then hence find the measure of angle A, correct to the nearest degree. So correct to the nearest degree will be a little bit of rounding. We have a triangle that we're going to take out separate to the original diagram. We have a 12, we have an A, we have Y over here, which we got to be 4. So again, H and A touch off the angle. You can see we're not using hypotenuse, so it has to be tan. So we say that the tan of A, opposite over adjacent, 4 over 12. You could write 1 over 3 if you want. You don't need to simplify it. So we're getting the inverse tan of 1 over 3 on our calculators. So you write down A is equal to, that's going to give me 18.43 degrees, and it says to the nearest degree, so the nearest degree A is equal to 18 degrees. So that's question 10. Question 11, we'll move over to the left here. A boy is flying a kite on a string 33 meters long. You can see the diagram here, so we could add to the diagram, we'd have a triangle. So let's take that triangle outside the question and redo it for ourselves. So you can see again, he's 1.5 meters above the ground here where he's holding it. So we'll have to bring that in at the end. So let's write this triangle here. We have 39 degrees. We have 33 meters. So we have two things in the triangle. That's all we need to find everything else. So the string, which is being held at 1.5 meters above the ground, makes an angle of 39 degrees with the horizontal. How high is the kite above the ground, right? So we'll just get this x over here, and we'll add on the 1.5 at the end. So what are we dealing with here? We have opposite, H and A touch off the angle. We have opposite and hypotenuse, so we're dealing with sine. The sine of 39 is equal to O over H, x over 33. So 33 by the sine of 39 degrees is equal to x. So just typing this into your calculator, you're going to get x to be, and it gives it correct to the nearest centimeter, but x is going to be 20.767. 20.767. We can add on our 1.5 meters to get 22.267, and in centimeters that's 2226.7 centimeters. So we're going to have 2227 centimeters. So be really careful in these questions, rounding off too early, converting from one unit to another unit, identifying what the diagram is kind of trying to trick you with, and you shouldn't have any problem with these practical questions within trig.